What if I told you the Atlantic Ocean has rivers inside it? Vast, moving highways of water that carry heat, salt, nutrients, and even shape weather across continents. From the warm Gulf Stream racing past North America to deep cold water sinking in the far North Atlantic, these currents help control climate, marine life, and global geography. In 2026, they remain one of the most important systems scientists are watching on Earth. Ocean currents are continuous movements of seawater. At the surface, they are mainly driven by global winds, Earth's rotation, and the Coriolis effect, which makes currents curve to the right in the northern hemisphere and to the left in the southern hemisphere. In the Atlantic, these forces organize surface water into huge circular systems called gyres. The North Atlantic subtropical gyre turns clockwise, while the South Atlantic subtropical gyre turns counterclockwise. These rotating systems are the basic geographic pattern behind Atlantic circulation. One of the most famous Atlantic currents is the Gulf Stream. It carries warm tropical water from the Gulf region into the Atlantic, then flows northward along the eastern coast of the United States and Canada before extending toward Europe. Because it transports so much heat, it helps keep parts of Western Europe much milder than other places at similar latitudes. That is why cities in Europe can feel far warmer in winter than places in northeastern Canada. The Gulf Stream is not acting alone. It is part of the wider North Atlantic gyre, linked with currents such as the North Atlantic Current and the Canary Current. But Atlantic circulation is not only a surface story. Deep below, temperature and salinity also matter. Cold, salty water is denser than warm, fresher water. So in the North Atlantic, some water cools, becomes heavier, and sinks. This helps drive a deep circulation system called the Atlantic Meridional Overturning Circulation, or AMOC. You can think of it as part of a giant conveyor belt. Warm water moves north near the surface, while colder, deep water returns southward below. This slow, overturning circulation helps redistribute heat, supports nutrient cycles, and plays a major role in Earth's climate system. These currents matter far beyond the ocean itself. They influence rainfall, storm tracks, coastal temperatures, fisheries, and ecosystems. Upwelling and circulation patterns help move nutrients through marine food webs. Currents also affect navigation, pollution pathways, and even where floating debris accumulates. In short, Atlantic currents connect physical geography with climate geography and human geography at the same time. So what is the big question in 2026? Scientists are closely monitoring whether the AMOC is weakening as the climate warms. Warmer ocean water is less likely to sink, and extra fresh water from melting ice can reduce salinity, making North Atlantic water less dense. Current assessments suggest the AMOC is likely to weaken during this century, although a complete collapse before 2100 is considered unlikely based on current evidence. Researchers continue to monitor the Atlantic carefully to better understand future changes and their possible impacts on climate. The Atlantic's currents are not just a pattern on a map, they are a living engine of the planet, and understanding them is essential for geography in the 21st century. If you enjoyed this video on global climate, please subscribe to our channel, Global Climate Now, and stay with us for more fascinating stories about our planet, climate, and environment. Thanks for watching.